Hello everyone, this is E542 and Lab4. The lab name is Fast Reliable File Transfer. So in this lab, we made our own protocol to transfer the 1 GB file. We are team 4, and the members of our team are 泽田照, Yang Jiang, and Chengwen Liu. Yeah, we named our protocol as SRP, which S stand for super, R stand for rapid, R stand for reliable, and P stand for protocol. And this overall strategy, I will make a detailed explanation with our flow chart. Yeah, this is our flow chart. So first, we start We start transmission. First server uh, have the file name and it construct the packets with our own headers and the data file. And then the server send packets over UDP to client as first time. And this step, server send all contents of file into packets and construct our own packets and use UDP to transmit them from server to client. And then after the first transmission, in the client side, we will make a judgment if client receive all packets, or if client receive all packets, the client will send the signal and exit. And when the server uh, receive the signal, and he will exit as well. So the program ends and the transmission is done. So what if the client don't receive all the packets? The client will send the sequence numbers of absence packets to server, and when server receive the sequence of these unreceived packets, he will retransmit packets to the client. And this is our procedure of all our protocol. And then I will let my teammate to make a experiment with our protocol.
Hi guys, this video is for E542 level 4. The first step, we can use this command to configure the byteways to 100 million bits per second on VOS, and this is for ETHO, and this is ETH1. Okay, the byteways has been limited to 100 million bits per second. Now we can use this command to see the delay and the drop rate of the ETHO with 10 million second delay and 1% lose rate. Now the MTU is 9001. For the first case, the delay VLS is 10 million seconds and the drop rate is 1%. And let's check the file size first. As you can see, the size is about 1 GB. And let's run our code on client and the server and send the file. As we can see, we use UDP protocol at first transmission. Okay, we can see the number of missing packets and the sequence number. And the server starts retransmit. And we can also see the receive sequence at the client. Okay, successful, and we can see the time consumed is 116 seconds, and we can see the throughput is about 70 million bits per second, and we can check the uh, hash code for the two file. Okay, it's A313. Yeah, it's the same for client and server. Let's continue. We can use this command to set the delay at 200 milliseconds and the lose rate at 20% for two network interfaces. Okay, let's run our client and check our file size. Okay, it's 1 GB, and start our server and insert our file name. Okay, TCP connection success, and server is sending the package. Okay, the file has sent to client, and the time consumed is 238 seconds, and the throughput is 34 million bits per second. And let's check the hash code. Okay, it's A313, and it's same on server. Now let's see the bandwidth of VLS at 8 million bits per second. Use this command to see the two network interfaces. Okay, and then we can use this command to set the delay in 200 milliseconds for VLS. Okay, we can use this command to set the bandwidth at 100 million bits per second on our client and the server. For ETH1, and the same operation on server. Okay, let's run our client and check the file size on server. Uh, it's 1 GB, and run our server. Okay. Uh, we can see the time consumed is 589 seconds, and the throughput is about 14 million bits per second. And let's check the hash code for the two files. Yeah, it's A313. Okay, it's same on both. Now we can use these two commands to set MTU to 1500 on VLS, and this for two interfaces, and we can check the configuration. Okay, this two comes to 1500. Okay, and it's a same operation to set the bedways to 100 million bit per second on VLS for the two network interfaces. Okay, and we can set the delay and loss rate through this command. Now we set the delay and the time milliseconds and the drop rate in 1%. Let's run our code on client. Okay, start client and check our file size on server. It's 1 GB and start our server. As we can see, the time consumed is 235 seconds, and the throughput is about 35 million bits per second. And let's check the hash code on client and the server. It's A313 and A313. Okay, it's the same. Next, we set the delay in 200 milliseconds and loss rate in 20% on VLS for two network interfaces. And let's run our code on client and check the file size on server. It's 1 GB, and run our server and input this file name. The file has been transferred to client, and we can see the time consumed is about 439 seconds, and the throughput is about uh, 18 million bits per second. And let's check the hash code on client and server. Yeah, it's A313 on client, A313 on server. It's the same. Okay, let's say the bandwidth at 8 million bit per second with this command. The two interfaces. And we can say the delay at 100 milliseconds for the two interfaces, and so the total delay is 200 milliseconds. And similarly, we can see the bandwidth at 100 million bit per second on client for ETH1, and it's same for server. We can use a command to save the bandwidth at 100 million bit per second. Okay, let's run our client first and check the file size. It's about 1 gigabyte, and run our server. Okay, the file has been sent to client, and the time is about 1208 seconds, and the throughput is six uh, six, and the throughput is about 8 million bits per second. And let's check the hash code on client and server. And it's A313 and A313, both client and server.